Hello, and welcome to this session of a new project in Excel. And what we're going to do in this project is we are going to create a dashboard that looks like this of work order data. Now, why would we want to create a dashboard that looks like this? Because we have programmers out there who create these big databases with user interfaces and some reporting capability, and they call them a complete program, but hardly ever do they include any kind of managerial reporting or to be able to look at the data in an analytical manner. Instead, they give you these reports you print out in paper, and there really isn't a lot of useful information in that information. Fortunately, most of the programs nowadays include the ability to export data. Not all of them do, though, but a lot of them do have the ability to export data in Excel, in an Excel format or a CVS format, which then allows us to take that data and create things like this dashboard that provides more analytical data than what we get out of the program that was created by the programmer. And I will just share, I had a conversation with a programmer one time who told me that accounting software had all of the features it needed. It didn't need anything else, that the programs were complete. This was back in a time whenever the programs were all in COBOL and were very limited and didn't have any kind of user interaction that allowed for dashboarding or any kind of analysis, and the reports were just basically data dumps. And I have found that a lot of programmers and IT people still feel that way, which is very interesting to me. Instead of listening to those people that their programs are supposed to be provided for. And so as you can see, what I've done is I've gone into the data set, and in order so that the data set itself isn't identifiable to any one organization, I've changed all people's names to Joe. And so you may see some interesting things like Joe and Joe changed Joe's and Joe's workstation or something like that. I've also changed all of the location names to names of towns in Texas. I didn't really go into the list of names in Texas and randomly sort them and choose them in that way. I just started at the top and went till I ran out of location names. That's why they're all starting with an A, except for Joe's office down here. And so as you can see, as I click on the different locations here in the slicer, it changes who we're looking at. And we have, let me choose somebody who's got quite a bit of activity. Here we go. So what we're looking here is at data for an entire year, and it's year to date. So if we had not finished a year, which a fiscal year of July to June, we would not show, for example, if we were only in February, then we would not show data for March, April, and May, and June, etc. What we're looking at is days aged. This section here is just for this office, Anton office, compared to all the locations. So we can kind of get an idea of how much work is the Anton office needing or having done compared to the rest of the locations. We're looking at days aged, and we go from 1 to 5, 6 to 10, and then 31 plus, etc. And then we have this little graph here for those who can't look at numbers like this and see a graph in their head. And there are those who prefer looking at just raw numbers like this, and that provides them the picture they need. And then there are those who prefer looking at a graph like this, and that provides them the picture they need. So this gives both perspectives. And then we have days aged for some stats here. We look at a min, a max, a mode, an average, a standard deviation, an interquartile range. And you can see down here in the notes, this is a measure of statistical dispersion. It is a robust statistic, having a breakdown point of 25% and is thus often preferred to total range. And then we have the median absolute deviation, and you can look down here in the notes and see that this is a robust measure of the variability of a sample of data. Then down here we have how many work orders were requested in a given month and how many were completed in that given month. So the ones that have the highest number are highlighted, so you can quickly see that in October we had 4 completed work orders. December we had 4 requested, 4 completed. January we had 4 completed. April 4 requested. And so the idea there is you can kind of hopefully see if there's a trend in when work orders are being requested and when they're being completed. Down here we see the crafts. Now we went with crafts, and you'll notice there isn't any worker analysis, and that's because this was a small shop that gave all of their work to be input into the system to their secretary. And so all work orders were assigned to the secretary because the secretary was the one who was updating the data, inputting the data, etc. So we really can't do an analysis by worker, which if we could, that would be something also that I would want to see on here. Another way at getting at that is looking at the crafts and the breakdown of the crafts. And we can see here we have all the crafts that are listed or available in the system. And we can see, for example, that 10, the highest, is miscellaneous, 6 general maintenance, 1 carpentry, etc., etc. And again, this shows the numbers for the selected location. Notice that this total 24 equals this total 24 up here. Compared to all, notice that the 467 agrees to the 467 here. And so we can see that 90% of the work orders, well, I was going to say the highest, but actually 97 is the highest, and that's in the miscellaneous category, 86 in general maintenance, and 90% that didn't have a craft assigned to it. Here is the work order status. We can see that out of the system as of the time of the data download, we had 0 closed work orders, we had 24 complete work orders, no new requests, and no work in progress. And here we can see that all, and again, this is just for the selected location. And then here we can see for all that we had 17 closed work orders, 448 completed, 1 new request, and 1 work in progress. Here we can see a work order status. This shows for this site, closed work orders, complete, etc. And since they are all complete, they show all complete. And then this shows a comparison of the work orders as a percentage to all. And so we can see that the work orders, the total work orders for the Anton office makes about 5% of all of the work orders. Now let's see if we can find something that has a little more interesting data. All right, let's look at the Allen office. Since this makes up 30% of the total work orders, and here we can see that we do have some closed work orders compared to complete, and we just have a little more data that we can look at. So this is what we're going to create from scratch, and we'll start with just the data. But before we get into that, did you hear about the lady who went to the doctor and said, Doctor, my daughter thinks she's a refrigerator. Doctor said, calm down, ma'am. I'm sure she will chill out. Hilarious. Those silly doctors. Okay, moving on. Here we're looking at the data as it looks whenever it is exported from the system. And it did have an Excel export feature, so we didn't have to go through a process of importing it through CVS or some other kind of text format. This number, I think this is just a random, a sequential number that is provided by the system. Then you have your work order ID. You have a description, door closer, etc., priority, status, craft, assigned. Notice it's all assigned to Joe Wise. I replaced, of course, the name of the secretary, as I mentioned before. Location, a building, area description, area number, custom category, days aged, request date, target completion date, actual completion date. And notice these are in a serial number format as opposed to a date format, which is all right. Created date, labor hours, total cost, action taken, requester name, purpose, and budget. And there was nothing put in budget. So the department didn't use the budget function of the system. And notice all the requesters are Joe, because again, I changed the names. One of the first things we want to do then is getting started and adjusting the data. The first thing we want to do is rename our tab to work order summary data. And we call it work order summary because that is the name of the report that we run in the system in order to export the data. So that gives us our hint so that whenever we're not dealing with this for a month and then we come back to do a new download, we'll remember, oh, okay, this is the report that we go to. And then we're going to make this a table. And we're going to name it TBL WO for work order data. I name all my tables starting with a TBL underscore. That way it sorts whenever I look into the name manager. It will sort according to TBL versus other names for ranges or something else. And that keeps all my tables together in this window. Plus, whenever I'm typing out formulas, it's easier, and I will show you that later, to type in TBL underscore to limit the list of options available in my formula to just my tables. Now we have created the table. We want to add some columns. Now, when you're pulling down data from systems, it isn't always going to have the data, all of the data you want, or the data in a format in which you want it to be in. And so what we do is we add columns to either break up data that is in one field that we don't want to be in one field, or to add additional data that will aid us in our analysis. And so in this case, what we're going to do is we're going to add a column here, and this is going to be request month, and it's going to equal month so it tells me that 7, the month of July, is what this represents. So before we can continue with this, we need to add some supporting tables. And so I'm going to add a new tab. We're going to refer to this as reference, as it will have our reference tables in it. And then we're going to create a table that has the month number, month description, and the fiscal year month. So our month number is 1, 2, 3, all the way down to 12. And it's going to be Jan, Feb, and the fiscal year month this is 6, 7, oops. This will be 7, 8, 9, 10, 11, 12, 1, 2, 3, 4, 5, 6. Format that as a table. We're going to call this TBL months. Now we come back here and we're going to create a column called request month description equals X lookup. Our lookup value is this, the request month. Our lookup array is TBL months, opening bracket, month number, closing bracket, and the return array is TBL. Now notice that when I type TBL, before I type TBL, I have all of these options here. And I don't want all these options. I don't want to have to scroll down and find TBL. Where's it? Oh, it's over here. Instead, by just typing this, I now have limited my list of options to just my tables and that one count if blank or count blank. So I hit tab, yes, open bracket, and I want month description, closing bracket, if not found, really is not a if not found. We do want an exact match, and we close that. I probably should put something in for if not found in case there is some kind of data input error, but really there shouldn't be. I can just check here real quick to see that there's not an error. Next, we're going to create the request fiscal year month. This also will be an XLOOKUP, so equals XLOOKUP, tab. To select that, our lookup value is going to again be the request month. Our lookup array is TBL, months, opening bracket, month number, closing bracket. Return array is TBL, months, opening bracket, fiscal year month, closing bracket, no error, 0. And now we have that. We're also going to create a complete month to find out, to give us a month of whenever a work order was completed. So this is going to be equal to month, and it's going to be actual completion date. Then we're going to have complete month description. So pretty much the same 3 columns that we have for the request, the information regarding the request. So equals that, equals XLOOKUP. Our lookup array is that value, comma, our lookup, that was a lookup value. Our lookup array is TBL, months, opening bracket, month number, closing bracket. Our return array is TBL, months, opening bracket, month description, closing bracket, no if not found, 0 exact match, done. Then we're going to have our complete fiscal year month. This equals XLOOKUP. I'm going to do this in here. Equals XLOOKUP. Our lookup value is here. Our lookup array is TBL, months, opening bracket, month number, closing bracket. Our return array is TBL, months, opening bracket, fiscal year month, closing bracket, no if not found, 0 exact match, and we're done. And that is it for our data. That's all that we want to add for our data. This is so that we can show kind of a shortcut for the description of the months as opposed to showing a 7 or showing the entire month. That allows us to show the data in a more compact form and getting it all onto a dashboard and not having, like we see here, where we're having to scroll back and forth to see things. That's what this allows us to do here. The request month and the fiscal year month just allows us to sort in order of whether we want to look at it by request month or by the fiscal year month. So the reason we choose months is because we're pulling the data down on a monthly basis. And so this allows us then to separate the data by month. So let's go to the reference tab and let's add a spillover. Now, what I did when I created this spreadsheet in the past, it was a long time ago, I actually added 2 additional tables. One was called locations, one was called crafts, that would drive the lists in the data validation feature. But instead, since we can now use a spillover as a way of doing that, which makes it dynamic, and I use the table because I knew if we added a site, I could go in and add a site. If we added the craft, I could go do that because I was the only one using the spreadsheet. But since we don't know, in this example, we want to try and make this as flexible as possible because we don't know who's going to use it. I don't know how you're going to use it. If you create something similar to this, we're going to create instead a spillover, which will dynamically update according to the data that's in the table itself. So this is going to be our location list, and we're going to do unique. And our array is TBL work order data, and it's the locations, or location, close bracket, and there you go. That gives us our spillover here. I'm going to bold that just so we know that that is a title. Then I'm going to come here, I'm going to do crafts equals unique. Our array is TBL, work order data, opening bracket, craft, closing bracket, closing parenthesis, and now we have our spillover for our crafts. And I'm going to bold that so that we see that's a title, that it's different than this down below. Maybe I'll do an underline too, maybe make that a little bit more obvious. And so now we are done. We are done with the work we needed to do for setting up the data and our reference tab. There will be one additional item that we'll add to the reference tab, but we're not there yet. We'll need to create the dashboard itself in order to do that. So thank you for joining me for this first episode, and hopefully you will join me in the future ones. Have a great day.